Heck yeah, we are getting close to completion on this one. You can see I've got the end effector all put together and ready to go. We've actually gotten some test prints out of it, and it is functioning, so awesome. In this first video, we'll just take a look at the end effector, some changes we had to make, and what went behind putting it together. And then the video after, we'll do electronics, and then that's pretty much it. We'll go over some of the changes I've made. I've put some new end stops in, some glass holders, spool holder, things like that. So there are some modifications that have already been made. But for now, just sit back and enjoy the extruder build and the end effector build. And then after that, we'll do some electronics. Here's everything we need to finish the end effector assembly. We've got our finished Z-probe here, which is just that little Allen key, a spring, and then a micro switch. This is going to be pushed down by the end effector. And you can hear the switch click there as it goes. That's going to help it level the bed so that it's very accurate on the Z-axis. And that's just a micro switch, the printed part, Allen key, spring, that kind of stuff. And then this part here is actually a safety pin that's been cut up into the proper shape. Now it's important to get the right size safety pin. The hole here has to be 2.5 millimeters. I went around and I bought a couple of safety pins locally, and these are the ones I found at Walmart. You can get a whole box of them, and if you look at the package, it's the size number 1. So those were perfect. Now the wire on this is this really nice 2-conductor shielded stuff. If you're ever looking for good shielded wire, take apart some old HDMI or DVI cables. I've got a ton of them laying around that have been broken over the ages or I've gotten for super cheap, and you can strip them apart and get a ton of nice shielded wire out of them, so it works pretty well for that. Next up, we've got the head. We've already prepared that, as you remember, with the Teflon tape up here and then down here as well. And then we've got this piece here, which is the fan bracket. I've got that aluminum tape on there to help keep the heat from deforming this bracket. That just slides on like so. And then you can see the holes on top where the screws actually bite in to keep this mounted. And then on the front of this, we've got this little 40 mil fan that's going to be blowing on it. Now we do that so we can keep the body of this nice and cool, because if this gets too hot, you're going to have filament melting inside of here instead of down at the very tip, and it's going to jam up and make a huge frickin' mess. Definitely don't want that. Now conversely, you can see this fan is going to be blowing on the block. We don't want to cool this down too much, because otherwise our little heater cartridge here, which fits in right here, is going to be working way too hard to keep this block hot, and it's not going to be able to keep a consistent temperature. Temperature is measured by this, a little thermistor. It just fits in this hole here, right next to the heater cartridge. That's the controller know how hot this is getting. Anyways, how are we going to keep the fan from cooling this off too much? You can use just Kapton tape and wrap it. That's actually how this came. This provides actually a little bit of thermal barrier, but after some research, I found that this stuff actually works really well, and I had a ton of it around from automotive work. It's just that fine fiberglass mat. Fiberglass thermally can take a ton of heat. I mean, it's just glass fiber, it's not going to melt on you. So I'm going to chop some of this up, wrap it nicely, and then we'll actually use the Kapton tape to kind of hold it in place. We'll make like a blanket of this stuff to keep this warm, and that should work really well. They actually use fiberglass filling for even stuff like turbo blankets, which get ridiculously hot. So we'll give that a shot, and hopefully that'll keep this hot end nice and efficient. The rest of the end effector preparation involves putting this push fit connector into that M5 hole that we threaded out earlier. Now, I did find one problem with this that's going to cause a design change. This is the original connector, which threads into here, and then the tube carrying the filament will go in here and carry it down. The problem is my hot end here has like a 1/4 inch gap from top to actually where the filament enters the hot end. So when you have this pushed into here and then mounted with the fan bracket, you've got that huge gap between where the filament comes out here and where it actually goes in the hot end, which gives it tons of space to jam up in there when you're initially feeding new filament in. Now that's something maybe I could back out the filament and keep going at it until it finally hit, but I really don't want to mess with that. So I'm going to go for broke here, and I'm actually going to drill out the center part and use the push fit connector that originally came with the hot end, which the crown of which actually goes around this here. and that tube makes a really nice solid contact with the inside of this. So there's very little gap for the filament to bunch up and get screwed up there. So yeah, we're going to swap this out after I drill the center hole out with one of the biggest drill bits I own. So wish me luck, and hopefully I won't have to order a new one of these when I screw it up. And there we are with the modified hole, and it didn't crack or anything like that, so hooray! If you do have to do something like this, I always find the trick best for cutting plastics or plexiglass or anything like that is actually to use a slightly dull drill bit. It won't dig in as much, and then take like a block of wood that has a decent diameter hole. Start out with a smaller bit and just put it down there. Hold down real tight on this while you're drilling. That keeps the piece from popping up and then, you know, bowing or getting cracked. And then you just progressively work your way up in the bits until you get to the size hole you want. Got the other pop fit connector set up there, and if we push the hot end in, it just sticks through nicely, and then we don't have any alignment problems or any weird gaps here, so we don't have to worry about jamming. So yeah, that fits real nice, and then we have plenty of room still for this guy to fit in. This is just the Z probe, and you can see it doesn't rub there and actually fits just barely in the slot there. There's our fully assembled hot end. Everything's put together and ready to go. We've got our central bundle of wires here, and for now it's just temporarily put together with these Velcro ties, because I got a feeling I'll be swapping some of this stuff out or having to mess with it until everything is settled in. Then we'll put some nice loom on it, so it looks pretty. There we've got our hair ties holding that right dead center so that when this moves, it pushes the cable bundle kind of out so it doesn't get caught in the tracks, because that would really suck. And that's working pretty well. So next up I'm going to put belts on just through the track here, and then we're going to figure out how we're going to mount the extruder and then get the hot end stuff wired up to the controller. So I'll get that done and then we'll check it in a minute. So here's the extruder body. I've already got the nut in here for the bearing, but preparation of this piece is probably the biggest pain out of all the plastic pieces. You've got to clear these channels nicely. You got to get this hole dimensioned properly, and then this area is the worst because it's got a bunch of rafts that run between that support this while printing, and if those are put in too heavy like they were in this case, you have to cut those out and then spend forever filing all this down so that your bearing here spins smoothly. It's a bit of an art to that to get it going, and actually what I'm going to do is I cut back a little bit more than I felt was necessary. And I know I've got them here somewhere. There we go. I've got some 5mm washers here that I'm just going to sandwich top and bottom on the bearing, so that when we tighten this guy down, it's not going to squeeze the bearing on the edges and stop it from spinning, but rather squeeze it in the middle where these washers are, so it can spin around the center like it should. This extruder is probably the most important mechanical piece, or not most important, but certainly it seems to be the one that jams up on most people, so we've got to be really careful with this. But when this is done and all assembled, that's just going to sit on top of this guy with that hobbed gear, and I'm hoping this one will work. Otherwise we'll be ordering another. But anyways, it sits on top of this geared stepper, and then that's where our filament's going to go in and where she's going to come out. So I'll get this all fiddled with here and fit nicely, and then we'll run some tests and see if it actually feeds filament like it should. Oops, we had our first major complication before I even bolted anything down, and that's that this hobbed gear doesn't go all the way down on the shaft and doesn't align inside the window here with the center of the filament path, and that's because the flat spot on this motor only goes about that far down. So what I'm going to try doing is actually flip this around and put it like this, since this isn't directional, and I'll see if I can get enough bite with that grub screw and if it lines up that way. So there's our extruder mounted, fully built. So since I didn't have the 3D printer to print the 3D parts to mount the 3D parts, I just had to resort to using this little piece of aluminum here that I bent down into kind of a J shape, and then mount it to the frame with some spacers so that I could run zip ties behind it and secure this in place for now. And it's actually pretty sturdy. The problem being, though, that this wiring has to run alongside of it, so that's not going to be permanent. One of the first things we'll print is an enclosure for this, and then some channel to hide all this wire, run underneath here, and then something more permanent to mount the extruder. Here's our temporary spool mounting here, just up on the ceiling. It's just a wooden dowel screwed up there. Eventually we'll have a hard drive bearing and something that's running across the top here, so the spool sits horizontally like that on its side. But for now, this will give us enough of a rolling start, so to speak, in order to print those parts that we need. So what I'll do now is I'll get this fed in to the printer, and then we'll feed it along here and measure to see how well the extruder is calibrated. Got the printer face up here ready to go, and we'll adjust that now and see what we get. Alright, so we're ready to start feeding this puppy up for the first time. So we'll just put the filament in there, and then I'm going to run about 200 millimeters through with the G-code command, and we'll see if it actually feeds it properly. That'll be interesting. Here we go. Haha, look at that. I don't know if you can see it on the camera, but it is filling the tube. Okay, let's do another 200 millimeters here. Here we go. It's rolling okay. Definitely not a permanent solution there. Okay, and we'll do another maybe 100 there. Should start popping out here. Hey, there we go. Alright, so we'll clip that, and what I'm going to do is start extruding 10 millimeters at a time and measuring it with the ruler, just until we get the right value here for extrusion rate. Once we can get 10 millimeter out at a time consistently, we're going to reattach this to the extruder, or yeah, to the hot end here, and then I can start the actual calibration process. So that's flippin' awesome. I'll get this trimmed now though, get that 10 millimeter sorted out, and we'll come back when we're ready to calibrate. That's it for the build of the hot end and filament systems. Everything's looking pretty good so far. In the next video, we'll take a look at the electronics and power supply, and then after that I'll show you some of the modifications we've made over the base design. But yeah, everything's looking great, and I think this is going to work perfectly once everything's together. Thanks for watching, and we'll see you on the next video.